Hello, this is Mr. Henry, and welcome to lesson 4.4, Equations in Two Variables. The essential question says, how do I find solutions and graph equations in two variables? Now, that might sound weird. When it says in two variables, think of that as with. So we're looking at two separate variables, usually x and y, and we'll get there. So the did you know says, did you know if your mom gave you $15 and you went to McDonald's to buy some milkshakes and french fries, you could actually use a formula to figure out all the possible combinations of everything you could buy. So if a milkshake is $3 and fries are $2, well, that's the formula you could use. So you could buy $3 times by the number of milkshakes you get, plus $2 times by the number of fries you get, and you equal a total of $15. And it says there were x is the number of milkshakes and y is the number of fries. So some possible examples. You could just do some guessing and checking on this. You could just buy 5 milkshakes. 5 milkshakes and no fries would give you $15. If you plugged in 5 here and a 0 there, 3 times 5 is 15 plus 0 is 15. So that would be $15. You could also go 3 milkshakes and 3 fries, or 1 milkshake and 6 fries, and there might be other possible combinations as well. Okay? But the point here is showing that a lot of times these equations can be useful. This seems like a pretty stupid example, but it's used quite a bit outside of the classroom. Okay, so we have 3 vocab words here. So in your vocab cards, we've got, first one is equation in two variables. And as we talked about earlier, it's basically just an equation with 2 variables, usually x and y. The reason why we usually use x and y variables is because shortly in this lesson, we're going to be graphing. And we have an x and a y axis when we graph, so we can use the x and the y variables in our problems that eventually we can turn into a graph. So if we use like a p and a q variable, you're going, well, there's no p and q axis. Okay, so that's why we usually use x and y. The next word is y-intercept. Now that one should be familiar. We talk about this is x-intercept, I'm sorry. X-intercept may not be familiar. The x-intercept is where your line crosses the x-axis. So it's the same thing as the y-intercept. So if I have a little graph here, and I draw a little line, boom. The x-intercept is where your line is crossing the x-axis. That is your x-intercept. We are familiar with the y-intercept, which is the other one. It's where your line crosses the y-axis. And the y-intercept happens when the x value is 0. So if you think about it on your graph, when you get an x value of 0, which is at the origin here, because you go 1, 2, 3, well, here's 0, that's where you're going to find your y-intercept. And it says here the x-intercept always happens when the y value is 0. If we go in the mark down our y-axis, so 5, 4, 3, 2, 1, 0. When the y value is 0, that's where you're going to find your x-intercept. Is that it? Yeah, that's it. So, example 1. Finding solutions of an equation in 2 variables. Fill in the table below and find solutions to the equation. Okay, so here I have an equation. And I have a little box, a little xy table, which, well, let's go ahead and throw in x, y. There we go. Now, in my little xy table, what I'm going to do is I'm going to find some solutions. Notice that's plural. It's not one solution. There are many solutions. As soon as you have more than one variable, there's a much bigger chance of having many, many infinite solutions. Okay, so for example, if I plug in, say, 0 for my x variable, now I'm going to take this equation here, just off to the side here, 2x plus y equals 2. And if I plug in 0 for x, see, I'm saying what happens if my x value is 0? If I plug in 0 for x, and I solve this equation, 2 times 0 is 0. 0 plus y equals 2. Well, I don't really need 0 plus y, so that's just y equals 2. So when my x value is 0, if my y value is 2, that makes this equation true. Check this out. If I plug in a 0 and a 2, 0, because 2 times 0 is 0, 0 plus 2 equals 2. It works. I found one solution to this problem. Okay, and we need to do it, well, 3 more times. So now we can come up with another number. I just came up with the number 0. I'll be honest with you, when I do this, I like to use small numbers, numbers close to 0, positive and negative. So I'm going to say, well, okay, what about if my x value is 1? Okay, so then 2 times 1 plus y equals 2. I took this equation here. Can I move it? Nice. I took that equation there. I plugged in a 1 for my x. Alright, so now I do the math. 2 times 1 is 2, plus y equals 2. To solve the equation for y, I'm going to subtract 2 on both sides, and y equals 0. So if my x value is 1, my y value needs to be 0 to make this equation true, because 2 times 1 plus 0 equals 2. Alright. Now, I'm going to show this, but did you know it's even possible to plug in a variable for the y and solve for x? Like, if we just said, okay, what if this is, say, 3? By the way, I'm picking one that I know is not going to work out to a super pretty answer. It's not going to be super bad, though. So you can just pick a y variable as well. You don't always have to pick x's. You can pick y's, you can pick x's. Now, the solving is pretty much the same. If I plug in a 3 for y in my equation, and I write down the rest of the equation and I solve here, I mean, that's just a two-step equation. So I subtract 3, subtract 3. 2x equals 2 minus 3 is negative 1. Divide by 2, divide by 2. These cancel. X equals negative 1/2. Okay, sure. That's what you get. That is the x value that goes with that y value that makes the equation true. Those two guys have to work together in a pair. The x and the y together make the equation true. Okay. We need one more. So I'm gonna, well, I have 0, I have a positive, I have a negative. Let's just go with a nice easy, like say 2. Why not? So 2 for my x variable plus y equals 2. So 2 times 2 is 4 plus y equals 2. To solve the equation, we have to subtract 4 on both sides, so these guys cancel. And y equals 2 minus 4 is negative 2. So we now have a positive 2 and a negative 2 together in my equation. That makes this equation true. Now, I've come up with 4 possible answers to this equation. I have the point, and by the way, these are points. These are ordered pairs. This is the ordered pair, 0, 2, 1, 0. Negative 1/2, 3. 2, negative 2. These are ordered pairs, x, y, x, y, x, y. These points are the solutions to this equation. If I go through and I graph these points, those points form the solution. And there are plenty more. There's actually going to be an infinite number of them, because this thing here is a line. And what I'm doing is I'm finding points on that line. Okay. Letter B. Okay, I'm going to move these guys to the other side. I can move him over just a teensy bit. Whoa, whoa. Control Z. Too much. There we go. Alright, so for letter B, I'm doing the same thing. I'm going to take the equation here. I'm going to say, okay, there's my x variable, there's my y variable. I'm going to plug in numbers into this equation. I'm going to make up my own x and y variables, and I'm going to plug them in and see what the other variable gives me. So I usually start with x, and you know what? I'm just gonna go. Okay, I want to plug in a -1, a 0, a 1, and a 2. I'm just gonna lay it out there out front. Those are numbers I'm picking. I'll be honest with you. Those are usually the numbers I pick because they're all small. There's close to 0. There's some positive. There's some negative. Those are the things I like to do. So when I plug in -1 for x, I'm going to solve my equation. So -2 times -1 is +2. And then to solve the equation, I'm going to subtract 2 on both sides. You always get rid of add and subtract before multiply and divide. So 2y equals -8. Now to get rid of my times by 2, I'm going to divide by 2 on both sides, and y equals -4. So when my y value is -1, the x value has to be -4. That would make this equation true. And let's do it again. Now, when x is 0, so I plug in 0 for my x variable. There's my line. All right, -2 times 0 is just 0. That's not really doing anything for me. I really don't even need to write that +0. Okay, so now there's my equation. So I divide by 2 on both sides, and y equals -3. Okay, and we do it again. And let's go with a pretty green this time. I'm going to plug in 1 for x. So if I plug in a 1, -2 plugged in 1 plus 2y equals -6. So I'm plugging in my 1 for my x. -2 times 1 is -2 plus 2y equals -6. Don't want to forget him. To solve the equation, we get rid of adds and subtracts before multiplies and divides. So I'm going to add 2 to cancel out this -2. So 2y equals -6 plus 2 is a -4. And now, since it's 2y, to solve here, I'm going to divide by 2 on both sides, and y equals -2. Are you noticing a pattern? When your y variables went up by 1, up by 1, up by 1, your x variable is going up by 1, up by 1. I'm going to make a prediction that I think this is going to be -1. -4, -3, -2. I think this is going to be -1. So let's see here. If I plug in 2 for my x, that's my last x variable I'm going to use, x value I should say. So I plug in 2 for x plus 2y equals -6. Let's see, that's going to be -4 plus 2y equals -6. We have our line down the equal sign. I need to add 4 to both sides. 2y equals -2. Divide by 2 on both sides, get the y by itself, and y is equal to -1. So this will follow a pattern. The lines that we are looking at are linear. I know, a linear line. That's kind of an oxymoron. Or not oxymoron, it's redundant. Lines are linear. That's what the word linear means. And because this is a linear equation, these lines are going to follow a pattern. And what we've found in the past, when we talked about slope, is the pattern of the equation is our slope. Okay? But for now, plugging in x variables, plugging in y variables into our equation, solve, 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 we get answer. So here's one for you to do. I would like you to copy down the equation and then do the problem. When you are ready to continue, hit play and we'll go through it together. Okay. Hopefully you did. So let's see what you did. So I'm going to plug in -1 and 0 and 1 and 2. Let's see what happens. So if I plug in -1 in for x, I write down the rest of my equation, and I solve. That's -4 minus y equals 0. I add 4 to both sides, and -y equals 0. Don't forget about that negative. A lot of people do. A lot of people, when you subtract or you add 4 here, you think that this sign goes with that 4. No, 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 no. This is a -y. He has to stay negative. And in case you're not sure, it is a -1y. Come on. So now we divide by -1 to cancel out this times by -1. And what the heck did I do up there? That's not a 0. That is a 4. 0 plus 4 is 4. So when I divide by -1 on both sides, I get an answer of -4. Okay. One down. We plugged in x value of -1. The y value is 4. We got ourselves an answer. And repeat. So if I plug in an x value of 0, 4 times 0 is 0. And like before, we don't really need to have the 0. We do need to keep the negative sign because it's a -y. It's not -0. We don't read it going this way across the page. We don't read from right to left. It's 0 minus y. So it's a -y, -y. So it's a -1y. I'm going to divide both sides by -1. These cancel, and y is equal to 0. 0 divided by -1 is 0. Okay, number 2 down. Number 3. I'm going to plug in a 1 for x. So 4 times 1 is 4. Minus y equals 0. I need to get rid of the add and subtract first before this multiply and divide. Remember, this is still a -1y. So if I subtract 4 here and subtract 4 here, these guys cancel out. I still have this -1y. And 0 minus 4 is -4. Divide both sides by -4, and y is equal to... I'm sorry, I'm not divided by -4. My brain's not working well today. Divide by -1, because it's -1y. So I divide by -1 on both sides. And so y is equal to a positive 4. Alright, last one. Now, I can use that same pattern. Look, I use a pattern with my x's, so there will be a pattern with the y's. -4, 0, 4. Each one here is adding 4. So I betcha, this next one down here is going to be an 8. So let's see here. Let's see if the pattern works out. When I plug in a 2 for my x, minus y equals 0, line. We multiply. 4 times 2 is 8, minus y equals 0. I need to subtract 8 on both sides to cancel him out. -y is equal to -8. Yep, don't forget about your negative. Divide both sides by -1, and y is equal to -8 divided by -1 is a positive 8, just like we predicted. Okay? So the pattern worked out. So we have now found how to find solutions to an equation with 2 variables. There are many, many solutions. I found 4 here. I could find them all day long and never find them all because it's infinite. I can plug in 10. I can plug in 100. I can plug in 1,000. I can plug in 5 and 9 and -2. I can plug in decimals. I can plug in fractions. And I'm still going to get an answer. Yes, decimals and fractions work. People get scared by them, but it works. If I plugged in an x value of, say, 1.2. Why not? Just to see what happens. If I plugged in 1.2 here, minus y equals 0, and I solve the equation, when I solve this, I'm going to find out what y variable would need to be here to make this stuff equal 0. So 4 times by 1.2 is 4.8 minus y equals 0. I'm subtracting 4.8 on both sides. Negative y is equal to negative 4.8, still negative 1. Divide by negative 1 on both sides, and y is equal to 4.8. So when my x value is 1.2, my y value is 4.8, that makes this stuff, the left side of the equation, equal 0. Okay? So any number you plug in could work. I like these numbers, negative 1, 0, 1, 2. There is no rule that says you have to use these. You can use any numbers you like. If you have your own favorite numbers you like to use them. That's just what I like. Now, next one says, based on the previous 3 problems, what... Oh, well, we need to answer this in a second. Before we get there, there's probably some directions that are supposed to be there. We need to graph our previous 3 solutions. So we're going to take this, and I'm going to graph them. So I'm going to take each of these problems. So this is letter A here. I'm going to take these points from this table, the points that we came up with, and I'm going to graph them on the space provided right here. All right? So here we go. And one thing I'm going to do, just to make everything nice and pretty, I'm going to take all of this stuff and I'm going to change it to, whoa, did not expect that. There we go. Change everything to red. And I'm going to take this guy and I'm going to change everything to blue. And I'm going to take the third one and change everything to green. That way when I'm graphing, we can make sure we're looking at the right things. Where's a nice pretty green? I like him. All right. Starting with the red line. Get my red marker out. Here we go. So I'm going to graph the point 0, 2. So on my graph, I'm going to find 0 in the x-axis, by the way. X-axis, y-axis, negative x, negative y. So 0 in the x-axis means I don't move sideways at all. It was 0, 2. So 2 in the y-axis means I go up 2. So that is my first point, 0, 2. You know what? Let me take him out of the way, because you guys can just look up your top of your page. I have to keep flipping, and I don't like this. So I'm going to take this. I'm going to group it together. I'm going to copy it and paste. Haha. Science. So now I don't have to keep flipping back pages. So the point 0, 2, 0 in x, 2 in y. Next, 1, 0. That is 1 positive 1 in the x direction, 0 in the y. Now, already I have a line started. 2 points define a line. If I would draw a line through these 2 points, you don't have to do that just yet. I'm showing, I'm demonstrating, I'm teaching here. If I draw this line, make it a little faded, I bet you the rest of my points are going to fit onto that line. So, negative 1/2, 3. Negative 1/2 would be right here. 1, 2, 3. Coincidence? I think not. This last point, 2, negative 2. That is 2 in x, negative 2 in y. Do you see how they all fit on the straight line? That's because the equation we came up with, this equation right here, is linear. I believe in one of the previous lessons we've talked about stuff in slope-intercept form. Y equals mx plus b. Yeah. Well, check this out. This, if you solve for y, you subtract 2x on both sides, becomes the equation y equals negative 2x plus 2. Meaning, this guy here, get him on the same page with everything else, this here crosses the y-axis at 2. That is our y-intercept. Here it is. And it has a slope of negative 2 over 1, meaning you go down 2 over 1, down 2 over 1, down 2 over 1, down 2. And you see my little gray line's a little off. But that is the same thing, okay? It's not a coincidence that it's going through those points. The points that we came up with are solutions to the equation. The line, when we solve in slope-intercept form, is the same line, okay? They're just multiple ways of showing the same thing. Actually, I'm going to do that. You can actually go through and you can draw this line in here now. So once you see the pattern, you can go ahead and you can fill in more points, down 2 over 1, down 2 over 1. Remember to go the whole way across the graph. You don't just do a tiny little section. Your lines are infinitely long. They go forever. And so we draw these little arrowheads on them. Boom, boom. Showing that they go on forever. Now I'm going to take this red line. Whoa, whoa, whoa. And I'm actually going to make them red. So this is from our first set of data. This is, actually, I'll even put the equation down here. Now I know that line comes from the equation y equals negative 2x plus 2. Or my original equation was here. Copy, paste. Where did it paste it? Way up there for some reason. Okay, so this is the graph of this line. This is some solutions of that equation. The graph is showing the solutions. It's a picture of all your answers. If I picked a point right here, that point right there is a solution to this equation. If I plugged in, say, the point, well, that's the point, 1, 2, 3, 4, 5, negative 8. 5 for x, negative 8 for y. I betcha, this will equal 2. 5 times 2 is 10. 10 plus negative 8, which is the same thing as 10 minus 8, is 2. It worked. All right? So I'm giving you the big picture here of what it is we're doing. Now, I'm going to get rid of this guy. I don't need him anymore. We're looking at Mr. Blue. Mr. Blue, Mr. Blue, come out to play. Paste. Uh-oh. Problem. Can I get all of it? There we go. Group, copy, paste. Nice. All right. Mr. Blue, let's see what you got here for us. I am on my blue marker already. So let's start graphing. Negative 1 in x, negative 4 in y. 1, 2, 3, 4. First dot. 0 in x, negative 3 in y. 1 in x, negative 2 in y. 2 in x, negative 1 in y. So I graph these points, x coordinate, y coordinate. That defines a line that is blue that goes like this. And it extends the whole way to the edge, both directions, and I can throw little arrowheads on my line. There. That is the graph of this equation. That is the graph of you copy, paste. That is the graph showing all of the answers for that equation. Every single point on the line is an answer to this. Even the ones in between the boxes, the fractions and the decimals and the uglies. All right, third one. I'm going to take all this, group, copy, and paste. Okay, I don't have the same color ugly green as that, but I've got this one. That's close. All right, green line. Negative 1 in y. I'm sorry, negative 1 in x, negative 4 in y. 1, 2, 3. Hey, those guys have the same first point. But this second point is 0, 0. That is your origin. Third point, 1, 4. 1, 2, 3, 4. 2, 8. 1, 2 in x. 8 in y, and even my ugly point, even that one I plugged in a decimal just to see what happened, 1.2 in x, 1, 2, 3, 4.8 in y. Whoa, that was an accident. It's just a little bit below the 5. Now, if I take my line tool and I change it to a nice ugly green and throw some arrowheads on it, and I start graphing, I try to make it go through my points. Okay, now obviously that little dot right there, if I can click on it, I can't, the line's in the way. That little dot right there, my graphing was a little bit off. But it should be right on the line. That's a mistake for me, not a mistake of this point. This point, the numbers are perfect. My estimation of where 1.2 is was off. Okay? And that came from this equation, which is right here. Again, the graph is showing a picture of every answer to the problem, including the fractions, the decimals, and the uglies in between the nice pretty points. I happen to get nice pretty answers of here and here. If I would have picked some ugly guys in between, I would get all these little dots. Okay? Now, I think we need to answer that question that I moved off to the side of the page. Delete them, pull him out. So, based on the previous 3 problems, those 3 problems you see right here, what can you predict about the graph of a line, or graph of an equation in the form of ax plus by equals c? What do they all look like? When you graph something that looks like this, by the way, this is called standard form. When you graph something that looks like that, what do you think it will always look like? Go ahead and pause the video. There's a space on your paper to write down your response. Try that right now. Okay, well, what'd you come up with? Probably, I kind of gave it away. They're all lines, they're linear, they're straight. So this equation down here, this is an equation of a straight line. This is called standard form. Okay, this is a way to graph a line similar to our slope-intercept form. In fact, this equation can be rewritten into slope-intercept form. Okay, so it is the equation of a line. Example 3. Complete the table and graph each equation. What the heck happened with that? There's a Q and not an A? That was weird. Alright, so we want to graph these things. So I'm going to start with my X, Y. So, you know, start the table X, Y. Remember, first one's always the X, second one's always the Y. Now this table is going sideways instead of up and down. So that just means all of these are my X's and all of these are my Y's. And this equation looks a bit different. This equation, if I can't just make up a number. I can't say that. Because look, if I plug in 0 for X, that's not true. So I can't just make up any number I want for X. I have some problems now. So what number could I put in here that makes this true? Well, the only number is the number 3. 3 equals 3. It's true. But what about the y variable? There's no place in here for y. There's no y at all, which actually means it doesn't matter. You can literally pick any y number you want. Whoa, what happened to my marker? Undo. So you can say like 2. Sure, why not? Now for the next one. What does the x variable have to be? It has to be the number 3. It's the only choice you have. That's the only thing the equation tells you. It tells you the x variable has to be 3. Look, x equals 3. 3, 3, 3, 3. It has to be 3. It can't be anything else. So then your y variables, there's no restrictions at all. It could be anything you want it to be. So 2, 0, -1, +1, you know, I like those numbers, right? So I use them a lot. So I'm just picking some numbers for my y variable. I'm keeping them small, near 0, just because, well, I like them. So when I graph this, x variable is 3, 1, 2, 3. Y variable is 2, 1, 2. There's my first point, the point 3, 2. Next one, x is 3, y is 0, 3, 0. 1, 2, 3 in x, 0 in y. 3, 3, negative 1. 1, 2, 3, negative 1. Do you see the pattern? It's like a vertical line going like this. 3, positive 1. 1, 2, 3, up 1. So this line is a vertical line. And that was really big, but you get the idea. It is a vertical line where all of these x values are 3. Right here has an x value of 3. Right here. And even the little in-betweeners. Right there. Let me get a different dot. Right there. And there. And there. And there. And all of these little guys. I'm just tapping away. All of them have an x value of 3. So all of those points make this equation true. And that's what the line's representing. It's representing every answer to that equation. All right, letter B. Y equals negative 2. Now, we could actually kind of do a little bit of logic here. Instead of filling out this table, check this out. Where on your graph is the y variable, the y value, negative 2? Most people start by going, oh, it's right there. I agree. That is the point 0, negative 2. See, my y variable is negative 2. X variable can be anything I want it to be. There is part of my line. Great. Well, where's the rest of it? Well, think. Where else is the y value negative 2? Well, right there. And right there. And there, and there, and there, and there. Everywhere along this line is where the y value equals negative 2. So these are all of your points. So you've got, say, well, I'm plugging in negative 2 because that's the only number that you can plug in for the y variable. 1 and negative 8 and, what about pi? So 1, 2, 3.14, right there is pi negative 2. Okay? It's okay. It's allowed. So there is where my y variable is negative 2. That's the equation of the line. Okay? There. Oh, that's a little thin. Now, it's your turn to try it too. So I want you to go ahead and pause the video. You don't have these equations written down on your paper. Write them down, fill in your tables, graph them on the space provided. You might be using the same space as the other two. I'm using a new space. And when you're ready, continue, hit play, and we'll go through it together. Okay, so let's see what we got. So we've got x equals negative 7. So where are your x values? Ugh, it's supposed to be a y. Don't try to save it, just fix it. Where are your x values negative 7? Because they all have to be negative 7 for this equation to be true. That is the only rule. X equals negative 7. Y can be anything you want. If you did 0, 1, 2, 3, that works for me. And we graph it. X of negative 7, whoop, 0. Negative 7, 1. Negative 7, 2. Negative 7, 3. There is where x equals negative 7, where all of your x's are negative 7. So if I make myself a pretty red line, not so thick. Oh, it looks, oh wait, I'm not on the line tool. Line, not so thick. Arrowheads right from here. And there we go. That line represents every answer to the equation x equals negative 7. even the ones I didn't put little dots at, right there, that's a solution. Okay, last one. Y equals 5. X, Y. I know all my y's have to be 5. It's the only thing that can be true. It doesn't matter what my x's are, but y has to be 5 because the equation says y is 5. So you make up some junk. I'm going to do it differently. I'm going to say 1.8 and 2.5 and negative 3.6 and 9/4. Yes, you probably went with nice, pretty easy numbers. I'm just being difficult and showing you that these guys still work. So when I graph 1.85, 1, 2, 3, 4, 5, right about here, and I graph 2.55, and I graph negative 3.6, negative 1, negative 2, negative 3, negative 3.65, and 9/4, which is 2 and 1/4, which is right in here somewhere. Look at them. They still form a straight line. Even with my ugly numbers, they still make a straight line. Because everywhere on this ugly line is where our y values are equal to 5. That has a y value of 5, and that one, and that one, and that one. So, a question for you, because this does confuse students, at least for a little while, is how can you tell if the graph will be a vertical line or horizontal? Will it be, how can you tell if this can be uppy, downy, or lefty, righty, or a diagonal slanty guy? So how can you tell the difference from looking at an equation if it's going to be one of those two things? So go ahead and pause the video, answer your question, let's see what you come up with. Look back at the notes if you need to. Did you come up with the number of variables? These guys have 2 variables in the equation, an x and a y. These guys only have 1 variable. It's either x or y. It's not both. Look back. There's just a y, just an x, just a y, just an x, and all of these 3 that I graphed up here had an x and a y. And that's what's going to happen is when you have 2 variables, it's going to have a 2-dimensional line. It's going to have a width and a height. A 1 variable equation will either have just a width or just a height, not both. All right, I believe this is the last one, I think. Example 4, application. Steve graphed 3 points of the equation. Negative x plus y equals negative 2. Then he drew a predicted line. Create a table of points and explain why Steve's graph is not correct. So Steve graphed these 3 points, boom, boom, boom. And I think Steve's just trying to be difficult because look at this line that he drew. Vroom, vroom. It's all over the place. But how can we prove to Steve that he's not right? How can we prove to Steve that he's wrong? I mean, I don't know if the equation does that. So what we'd have to do, what we're going to do is, well, what the problem asked us to do. It asked us to take the equation, which I'm making space to write, negative x plus y equals negative 2. And if we start plugging in some more points in here, we have a couple. Let's get some more. If we plug in some more points here, let's see what we come up with. So 0, negative 1. How about a 1 and a negative 2 and a 4 and a 5? Let's just get started with that. So if I plug in 1 in for my x, negative 1 plus y equals negative 2. And I solve. Add 1, y equals negative 1. That was easy. Okay. So the point 1, negative 1 is what I found. Now, that fits in with our ideas that this should be a straight line. So we know that, what was this guy's name? Steve. We know that Steve is not right, that the graph does not go up here. It cannot go up here because it has to go through this. And Steve goes, okay, fine. Well, how do you know it doesn't do that? Well, then we do our next one. And if we keep doing these points over and over and over, this is probably tricky for some of you, this one, because it's a negative. And I've seen this mistake even in my classes this past week or two, because there's a negative out front here, but the x is also negative. So you have this negative, -2 plus y equals -2. And a negative, -2 does change to a positive. Most students understand that, but a lot of folks are forgetting that one. So this negative, -2 becomes a positive 2 plus y equals -2. You subtract 2 on both sides, and y equals -4. Okay. So when my x variable is -2, 1, 2, my y variable is -4, 1, 2, 3, 4. Fits in with our ideas that this should be a straight line. I'm just getting rid of some of the junk, that's all. Fits in our idea of the straight line, and not Steve's idea that it might be curvy. And we keep going. All right, 4. So, oh, I need to get rid of these parentheses up here too. So -4 plus y equals -2. I'm plugging my x variable of 4 in for x. And to solve, I'm going to add 4 to both sides, and y is equal to 2. 1, 2, 3, 4 in x, 1, 2 in y. Still fits in with our idea of a straight line. There's the straight line that our points seem to be going through. Right? 5. I can make a prediction. Actually, we both have the same prediction. It's going to go through this point right here. So let's see. If I plug in 5 in for x plus y equals -2, I add 5 to both sides, and y is equal to 3. 1, 2, 3, 4, 5. 1, 2, 3. Okay, so we both kind of agreed there. What about like in between it? Like, how do you know Steve doesn't go? Why doesn't it just go like this? Boom, 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 boom. Well, we can come up with some of those weirder ones. Like I could say, like 1.5 for x. -1.5 plus y equals -2. If I add 1.5 to both sides to solve my equation, y is equal to -2 plus 1.5 is a -0.5. So if I get rid of this line, 1.5 in x, -0.5 in y still fits on our line and not on Steve's line. Okay? And last one, we got to do one more just to fill in our table, and we pick any point we want. So let's do -3. I was looking at my graph here, and I'd like to get some stuff down here. So -3, I'm making a prediction. It's going to be 1, 2, 3, 4. I think it's going to be at -5. That's my prediction. -3 plus, whoa, I messed up. See, I did that thing that I said a bunch of my students did. Because it's a -3, I need my other negative out front. It's a -3. The opposite of -3 plus y. Okay? So that becomes just a +3. Subtract 3 on both sides, and y is equal to -5. And that's what we thought it was going to be. Okay? And this has been lesson 4.4. Thank you for watching. Bye-bye.